Which Newman projection represents the most stable conformation of 3-methylpentane when viewed down the 2,3 carbon carbon bond? So, first of all, here is 3-methylpentane, so it's symmetric. You could number 1 this way or 1 this way, right? So like 1, 2, 3. So this Newman projection shows that bond right there. So right, Newman projections and stability. So least stable Newman projection would be eclipsed, right? When these guys are, I'll just use blue here, when these guys are over top of each other, right? So when it's like, right, this, right? And let's say you have two groups, X and Y, when they're eclipsed like that, that's the least stable. Okay? So basically the further apart these guys are, the main groups, the non-hydrogen groups, right, the more stable it's going to be. So there's the Gauss interaction, hopefully you remember, right? So that's when you have two things like X, Y, right? When they're not eclipsed, but one further rotation away, right? So Gauss interactions are what we're looking for to compare these in stability, right? So A, for example, has one Gauss interaction here. Let's see, C has one here. B has two, right? This one and this one. D has two also. So B and D have more Gauss interactions than A and C, right? So we can cross those off right away. Also, D is a completely different compound. It has an extra methyl, so if I added another methyl here or something, right, then I'd get D. Right, but hopefully you can tell that this is a different compound than the other guys. So this, for these Gaussian interactions, this guy is less stable than this guy because this is a bigger group, right? So steric interactions and Newman projections in the chair conformation of cyclohexane, right? The bigger the substituent, the more steric interaction, just on size. Nothing to do with electronegativity or that. It's just size, strictly size. So these are two methyl groups, and this is a methyl and an ethyl. The ethyl is bigger than a methyl, so this is a greater Gauss interaction, requiring more energy, making it less stable, leaving A to be the most stable.